Hello Ninja Warriors. Today's session is going to be all about integral calculus. I know that you have been waiting for this class since very long. I was facing some challenges to start the class, to initiate the class, but it is happening right now. So before I start any further, you have to do something for me, right? You have to like the session right away and you have to share the session with your fellow CBSE students, okay? So this is me, your Ninja ma'am, with your 5 days planner. I hope that you have seen this differential equation mega marathon calculus which has happened today. Done and dusted, okay? Now day 2 integral calculus mega marathon. Today we are going to majorly focus upon integration, that is going to be definite and indefinite integration, okay? So indefinite plus definite, along with that differential equation is going to be there, okay? So complete integral calculus. Now let's see if at all we are not able to finish area under curve today, okay? Area under curve, I'm not going to take more time in that. If at all not today, I'm going to include it tomorrow, because today we have 100 MCQs also. So I want this session to get started by 6 o'clock, okay? So by 6 we will start, and by 8 o'clock we'll be able to finish this 100 MCQ. So today's session day 2, then you can see day 3, day 4, day 5, the complete schedule. The sessions are already live on Vedantu JEE English channel, okay? Okay, so I can see Aslam is saying sums with volume of cone and cylinder. Yes, I will be bringing you 200 plus PYQs. It will contain all variety questions, okay? So do not worry about questions, if at all, each and everything in 200 plus PYQs, okay? So here this session is going to be all about conceptual, that how to do something, okay? Then on 7th March, you can see a carbon copy or current year guess question paper we are going to do. Then paper presentation we are going to write, and last minute short questions, just to make sure that you are not missing out on very important thing. Then we are going to have last minute revision of mathematics on 8th March, 5 o'clock in the morning, okay? All right, so I can see Joshit is saying Vanakkam. So Vanakkam all dear students, and yesterday I have learnt amazing words from Telugu, Tamil and Kannada as well, okay? So why my no, I am louder. I voice breaking, you are guys say. Voice breaking. Voice is fine. Now better. Let me check by myself. See about questions. If at all, one question or one category I'm not covering in. So I think my mic was down. I think it's better now. Is it better? Tell me, is it better? You can hear me properly, right? All clear, all clear, all clear. Audible? Better? Better? It is low. Is it low? Voice is like dull. No. Okay. Let me try increasing my pitch, okay? Let me try increasing my pitch, okay? I have a relatively lower tone of pitch, so that is what is. Yeah, I am okay. All right, let's start. Why are you saying I'm not okay? So this unit-wise breakage, I hope that you guys are aware. Relations and functions 8 marks. Algebra is 10 marks. Calculus 35 marks. So yesterday we were done and dusted with 14 marks from calculus. Today's session is going to be all about rest of the marks, that is 25 marks we are going to get from today's session only. Then we have vector, linear programming, probability. Now if you talk about chapter wise breakage, you can see that these 3 chapters are from, you can see, right, these 3 chapters, 9 plus 6, 15 plus 7 to 22 marks we are going to cover in today's session. 22 good marks. Let's set the intention that what we are going to do is 22 marks we are not going to tolerate, even if We don't have to lose even 1 mark. We can't afford to lose 1 mark. Why? Because we want to get 80 on 80 in mathematics. That's what I wanted to mention. So today's session, let's start. Before I start any further, for all of those who are new to the channel, new to the session, this is me, your ninja ma'am, Namrata ma'am, and I have been teaching for more than over 10 years in both online and offline. So since a decade, I am teaching, okay, and mentoring JEE aspirants, and I am teaching for your CBSE boards as well. So without any further ado, let's start today's session. Today I have kept some white slides. I hope the slides are visible. Slides are visible. Okay. All right. Do just these questions. Do not feel low. Do these questions. Just follow all my marathons. Follow all my notes. You have to practice on your own. It can't be you just sitting and watching. Mathematics is not like that. So you have to solve. So make sure that you're bringing pen and paper, because this is not a Netflix series, right? Okay. All right. Clear. Chalo. Let's start. So you know that integration is a reverse process of differentiation, correct or not? So suppose you are having a function, okay, 3x square plus 7x minus 2. Yesterday we have seen that how to differentiate a function. So if you differentiate it, you are going to get 6x plus 7. Now if you want to integrate 6x plus 7, definitely you are going to get this. So differentiate and integrate. So this is your integration. Antiderivative is nothing but integration, right? So in this session, we are going to cover all the MCQs also, okay? And some standard integration. Let's talk about that first. So very first thing is x raised to power n. Integration of x raised to power n is what? Tell me. So integration of x raised to power n is x raised to power n plus 1 upon n plus 1, okay? Then integration of x cube is the example. Integration of x cube is x raised to power 4 plus 4. Very basic, okay? Integration of 1 by x will be log x. Integration of e raised to power x will be e raised to power x. Integration of a raised to power x is, remember, a power x upon log a. So your log a will be in the denominator. Similarly, can you see example? Integral of 2 power x is 2 power x upon log of 2. Integration of sine is negative cos x. Now understand here, so many students get confused. So many students get confused that, ma'am, what is happening over here? Because see, you know that derivative of sine x is cos x. So that is why integration of cos x is sine x. And you also know that derivative of cos x is minus sine x. That is why integration of sine x is minus cos x. So just understand that both are reverse process of each other, okay? All right. Now some integration that you all should remember, huh? I'm not gonna remind you. Now just start learning it, start remembering it right away. Integration of sec square x is tan x. Integration of cosec square. Yesterday also I told you, right? Whenever there is a co in the beginning, can you see the co in the beginning? You can see a negative sign. So derivative of sec square x is tan x. Derivative of cosec square x is minus cot x. Okay. Derivative of tan is minus log cos x. Or you can also write it as log of mod of sec x plus c. This is also one of the answers, correct? Integration of cot x will be log of mod of sin x. So these are very important. I'm going to use it in today's session. Okay. Why it is called as anti-derivative? Because it is the reverse process of integration. Integration of sec x is log sec x plus tan x. Integration of cosec x is log cosec x minus cot x. This is also very important. Integration of sec x tan x is sec x. Just tell me one thing, acha, one question. One question from you all. One question from you, for you all. One question. This session is not going to be more than so we started at 2, right? Let's wind up this session by 5:30 p.m. What do you think? 5:30? Okay. Volume is fine. Why are you saying about volume, gaming, Jashan? Okay. Now just tell me what is the derivative of sec x. I am standing right here. Derivative of sec x in the chat box. Yesterday we did differential calculus, right? Differentiation. Just tell me one thing. This weightage is for, oops. Okay, sec x tan x. So that is why integration of sec x tan x is sec x. Okay. Now let us talk about some basics theorem of integration. I'm gonna skip it. Let's skip it. Let's skip it. No need to study this. Okay. Let's start with problem solving. What do you think? Let's start with one MCQ. Right? MCQ. Okay. Are we ready for this MCQ? Let's see how to solve this question. Okay. So integration of sec x upon sec x minus tan x dx. Okay. So now what I'm going to do is, I am going to multiply and divide. How to solve this? Multiply and divide sec x plus tan x upon sec x plus tan x. Okay, ma'am, why are you doing this? Because see, sec x minus tan x in the denominator, because the denominator is troubling me now. I'm not able to integrate just because of denominator, because if things are completely in numerator, I'm fine. But when things are in denominator, I'm not able to integrate, right? So if over here, this is sec square x integration plus this is what? Sec x tan x integration. Yes or no? And what about, ma'am, denominator? Denominator is a minus b, a plus b. Sec x minus tan x into sec x plus tan x is what? Sec square x minus tan square x, which is nothing but 1, my dear students. 1, 1, 1. Right or wrong? So the moment you multiply the denominator, denominator is 1. So this denominator is 1. What about numerator? Sec square x plus sec x tan x. Integration of sec square x is tan x. Integration of sec x tan x is sec x plus constant. So sec x plus tan x plus c is the correct answer. B for just biryani. Right? Just biryani. So biryani is the correct answer of this question. Let us move on to the next problem. Can you see very easy MCQs they will ask? Let's boost our confidence. What do you think? Let's boost our confidence. Okay. So, e power 5 log x, correct? E power log of x power 5 integral dx. Okay. This is e power log of x power 5. X power 5 integration. So x power 5 integration is x power 6 by 6 plus constant. Can you see easy peasy lemon squeezy questions? Okay, this is a PYQ. I'm not even, you will be like, ma'am, you are bringing only easy questions. No, PYQs only, okay. So now, let us talk about some next, like not very easy. Let us take a step higher. Let's talk about integration by substitution, integration by partial fraction and integration by parts. These three things are there which are important for your integration CBSE boards, correct? Okay, so yes, let's start. So first of all, let's start this integration by substitution. Okay, integration by substitution. Okay, so over here what we need to do is, first of all, x into root 1 plus 2x. This was the question which was asked in CBSE 2024. So whenever you see square root, okay, square root of algebraic function, what to do? Acha, you tell me. You tell me. Okay, you tell me. So this is 1 plus 2x is equal to t square. You need to substitute 1 plus 2x is equals to t square. Now this is going to become 2 dx is equals to 2t dt. Correct? 2 dx is equals to 2. Let's substitute. Integration. X is there. Now x will be what? From here just calculate the value of x. So this is t square minus 1 upon 2. X will be what? T square. So this x will be replaced by t square minus 1 upon 2. And what about this? This is what? Square root 1 plus 2x, correct? So this is what? T square. So this is into t. And now you know that 2 dx is equals to t dt. So dx is equals to, this is again t dt. So this is what your question has become. Now this integration of this is very, very easy, right or wrong? So this is going to become what? T square minus 1. So t power 4 minus t square by 2 integral, and this is your dt. T power 5 by 10 minus t cube by 6 plus constant of integration, right? Plus constant of integration. Okay. All right. Yes. So this is your correct answer. So what is the correct answer? Tell me. T power 5 by 5. Yes. Now let us just resubstitute the value of t. Can anybody tell me what is t? From here square root 1 plus 2x is equal to t. Just put it over here. So 1 plus 2x raised to power 5 by 2 minus 1 plus 2x raised to power 3 by 2. Correct? This is upon 10. This is upon 6 plus constant. Final answer of this question. Yes or no? Yes or no? Okay. Once again, you guys are saying, see, whenever you see square root, always think about that this square root will be equals to t, or 1 plus 2x will be t square. Same thing now. Either you put, see, either you put, understand. So 1 root 1 plus 2x I am going to put as t. Just tell me one thing, that 1 plus 2x will be what? T square. Correct? 1 plus 2x will be t square. Now, what we are going to do, we are differentiating both the sides. Differentiate, this is integration by substitution. Differentiate both the sides. If you differentiate, you will get this. So dx is coming out as t dt. So this dx I am going to replace by t dt. Correct or not? Yes, ma'am. What about this? I am going to replace this by again t. What about x? To calculate the value of x, you just need to shift. So t square minus 1 upon 2, this is the value of x. So just put the value of x in terms of t. So this is x. This is square root 1 plus 2x. This is your dx. Now just multiply together. T square into t square is t power 4. Then we have 1 into t square is t square. Now integrate. T power 4 ka integration is t power 5 by 5. But 2 was already there, that is why 10. This is t square integration is t cube by 3. But this has become 6. Now you just need to plug in the value of t right here. Okay. Alright. This is how you substitute. This is how you solve question by substitution. Okay. Alright. Yes. Perfect. Okay. Chalo. Let's start now. I'm gonna tell you about partial fractions. Okay. So let's talk about partial fractions. So this is integration by substitution. Can you see? Integration by substitution. Now we have integration by partial fraction. So let us understand how to integrate by partial fraction. Okay. So over here we are having partial fraction, but here, okay. But before that, let us learn some standard formulas. Okay. So integration by substitution is there, but let us just first of all focus on standard formula. What is integration of tan x? Can anybody tell me, ma'am? Integration of tan x is log of mod of sec x. Integration of cot x is what? Log of sin x. Integration of sec x is what? Log of sec x plus tan x. Integration of cosec x is what? Minus log mod cosec x plus cot x. So these are the some standard integration that you all should remember. Okay. Now let's talk about something which is standard substitution. Okay. So this is basics. This is just basics. So whenever you see an expression of the form a square minus x square, okay, a square minus x square. So think about integration. Basically, you need to substitute trigonometric substitution. This is trigonometric substitution. Trigonometric substitution. Trigonometric substitution. Okay. Clear? Trigonometric substitution. So whenever you see square root a square minus x square, it is going to become a sin theta or a cos theta. So if you plug in a sin theta, tell me what will happen. It will be a square minus a square. This is going to give you sin square theta or cos square theta. So understand, out of 6 trigonometric ratio, only 2 will work. If you put tan theta over here, 1 minus tan square theta, there is no identity. If you put sec theta, no, only sin and cos will work. Similarly, if I talk about this, square root x square plus a square. So here, so whenever you see x square plus a square, you will see that x is a tan theta or a cot theta, correct? Third one will be what? Square root of x square minus a square or 1 upon square root of x square minus a square. So over here, we need to put x equals to a sec theta because sec square theta minus 1 makes sense, right? Sec square theta minus 1 makes sense, okay? What, you guys are asking some doubts kya? Asking some doubts or what? Now there are some formulas which I want you to by heart, some formulas which are, see, integration of some particular functions. Okay, so this is some standard formula again. So 1 upon x square minus a square is 1 by 2a log x minus a upon x plus a. 1 upon a square minus a square will be what? Tell me, 1 upon 2a log a plus x upon a minus x. Then third will be, see, 1 upon x square plus is. Now I want your maximum attention over here because this third formula and fifth formula, I think most of you might be aware about it. Ma'am, yes, we know tan inverse and sin inverse, but did you see that this is 1 upon x square plus a square? So there is 1 by a written in front, and this is 1 upon square root a square minus a x square. 1 by a is not written in front, right? 1 by a is not written in front. Cool? Okay. All right. Now we are having, can you see the next, some more formulas, okay, some more formulas you can see. 1 upon square root x square plus a square. Now you'll be like, ma'am, how to remember such formulas? Do not worry, Ninja ma'am is here. So 1 upon square root x square plus a square will be log of x plus copy paste. Remember, log of x plus copy paste, okay, log of x plus copy paste. And over here, 1 upon square root x square minus a square will be log of x plus copy paste. So these two must be remembered together. Don't you think? These two formulas must be remembered together. Okay. Alright. Now we are having this. Whenever you see 1 upon quadratic, 1 upon quadratic. Now this question you might see. 1 upon quadratic. Remember that you have to create a perfect square. Just create a perfect square and you will be sorted. That's it. So this is, no need to read all this. Whenever the question comes, we'll be doing this, okay. So now let us move on to partial fraction, okay. So let's do partial fraction, okay. So now partial fraction means, so there will be some complicated polynomial upon polynomial function. So let me just tell you this type of function. Can you see this mixed bag function? Okay, so where denominator will be factor of two different things. Can you see? This is also denominator. I want to separate out. So it seems that somebody has taken LCM out of it and clubbed two terms together. I want to separate it out. Are you getting my point? So you want to separate it out. Okay, so how to separate it out? Using partial fraction. Okay, so this is the table of partial fraction. You can see, you can remember also. Okay, so whenever you have two linear expressions in the denominator, then go with this one. Two linear expressions in the denominator. Okay, so what you need to write is constant upon x minus a plus b upon x minus b. Let me show it to you before I just tell you. Let me just do one question for this. Okay, do one question for this. So students are saying, ma'am, put x square is equals to t. Yes. So first of all, this is, by the way, 2024 problem. Put x square is equals to t. Putting x square is equals to t right here. But you know what? This is not the substitution. Understand? This is not a substitution. I'm not going to differentiate it. So what I'm going to do is, see, understand. This is the expression. I'm just taking out the expression which is inside the integral. And for the time being, there is a difference in this substitution. For the time being, I am just treating x square as t. This is not a integration substitution. This is a different thing. So x square is nothing but what? T, and just this is going to become t upon t plus 4 and t plus 9. Okay, t upon t plus 4, t plus 9. So t upon t plus 4 and t plus 9 is equals to a upon t plus 4 plus b upon t plus 9. Correct or not? Now just calculate the value of a and b. Correct? This is a t plus 9 plus b t plus 4 and this is your t. Correct? So 1 is equals to a plus b and 0 is equals to 9a plus 4b. 1 is equals to a plus b, 0 is equals to 9a plus 4b. So now if you solve it, you will get the value of a and b. How will you get it? Multiply it by 4 and subtract. So if you multiply it by 4, you are going to get what? A is going to be multiplied by 4 and subtract. So this is 4a minus 9a. So minus 5a and b cancel and this is 4. So a is equals to minus 4 by 5. Similarly, the value of b will be what? This is 9 by 5. Yes or no? Now you can peacefully integrate. Okay. So now this is what? A upon. So this expression is a upon. So a is minus 4 by 5 upon x square plus 4 plus we are having 9 upon 5 x square plus 9. This is dx. This is dx. Okay. So minus 4 by 5 will remain outside. This is what? Integration of 1 upon x square plus a square. Come on. Oh, why are you saying log? Why are you saying log? Log. This is tan inverse clearly. Please log while students go away. This is tan inverse. Remember that formula. Integration of 1 upon x square plus a square. Tell me what is the formula? Ma'am, 1 upon a tan inverse x by a plus c. Yes or no? So please make sure that you are writing this formula in the box. And this is what? Tan inverse. This is x by 2 and this is 1 by a, so 1 by 2. Plus 9 by 5 into 1 by 2 tan inverse x by 3 plus constant. This is your final answer. Okay, tan inverse. Okay. A plus 2b is 1. Why a plus 2b is 1? A plus 2b, how come a plus 2b is 1? Everybody got it? So this is minus 2 by 5 tan inverse x by 2 plus 9 by 10 tan inverse x by 3 plus integration of constant. Okay. One more question, let's do it. One more question. Half, ma'am, not. Okay, so this is 1 by 3, sorry. So this is 15. So 3 3s are 9, na? 3 by 5. So 3 by 5. Better? Okay, so let me just reveal the solution also. This is what we have done. Understand now. One more time, students are saying. So first of all, this was the integration. Let us forget about the integration for the time being. Let us focus on this. For the time being, I am putting x square is equals to t just for the simplicity. So this will be my, now this format, you know the partial fraction format. When there are two linear factors in the denominator, it will be written by a upon linear, b upon another linear. Now how to find a and b? How to find a and b? So to find a and b, understand what did I do? I just took an LCM. A into t plus 9, b into t plus 4 is equals to t. So clearly over here, can you see a plus b is 1 and 9a plus 4b is 0. Correct? Okay. So now two equations, two unknowns, get the value of a, get the value of b, and eventually now this, if you put a and b over here, a will be minus 4 by 5 upon x square plus 4, written right here. B will be 9 by 5 upon x square plus 9. Now integrate this. Now integrate this. Yes? Okay. Alright. One more question let's do from partial fraction. Are we ready? Or again from 2024. 2 marker question, 3 marker question they can give. Okay? Okay. Let's do it. Partial fraction. Okay. Integration of 1 upon x square minus 1. Now understand that this is okay. So what we can do is, one way is just write 1 upon, okay, just write 1 upon x plus 1, x minus 1 dx. Okay, method number 1 I am telling you, method number 1, both methods I'll tell you. So this is again, ma'am, denominator is like product of 3 linear functions. So yes, can it be done by partial fraction? Definitely it can be done by partial fraction. How come? Ma'am, the expression is 1 upon x plus 1, x minus 1. It can be written down as a upon x plus b upon x plus 1 plus c upon x minus 1. Correct? Now if you take LCM on the right hand side, this is going to give you a, x plus 1, x minus 1 plus b, this is x square minus x plus c, this is x square plus x. Okay, if you take LCM, and this is 1. The denominators will get cancelled out. Do you know how to take LCM? Just I have taken LCM. A will get multiplied with these two, x square minus 1. Can you see? B will get multiplied with this and this, x square minus x, and so on. Okay, alright. Now understand. Just tell me on the left hand side, what is the coefficient of x square? Ma'am, coefficient of x square is 0. On the right hand side, what is the coefficient of x square, ma'am? Here a, then b, then c. Okay. What is next? Coefficient of x on the right hand side is 0. On the right hand side, coefficient of x is missing over here. Here the coefficient of x is minus b plus c. Third equation, my dear students. On the left hand side, you can see a constant term which is 1. On the right hand side, only constant term is minus a. So a is coming out as minus 1. Right? A is coming out as minus 1. So this is a is minus 1. So minus 1 by x. Plus, if a is minus 1, so this is going to give you what? B plus c is equals to 1. And minus b plus c is equals to 0. If you add these two, 2c is equals to 1, c is half. So this c is half. This is half upon x minus 1. If c is half, b and c are equal, right? B is also half. So this is half upon x plus 1. This is integral dx. This is integral dx, integral dx. Okay. So this is minus of log of mod x plus half log of mod of x plus 1 plus half mod of log of mod of x minus 1 plus c is the answer. Correct? Now, what we are going to do is we are going to arrange it. Arrange it, okay? So, if you want to arrange it, understand that I am going to multiply half 2 by 2 over here so that I can take half common. So, if I take half common, what is going to be the answer? Just tell me, half common. So log x plus 1 plus log x minus 1 plus log x square. Okay, plus constant. So half will be there. This is log x plus 1. So this is x square minus 1, correct, upon x square. This is a negative sign. Plus c. This is the final answer. This answer will be the final answer. Getting it? Understanding it? Understood. Ma'am, solving for A can't understand. Solving for A can't understand. Okay, solving for A. We are just equating the coefficient. First of all, this was the initial thing. I hope that everybody has understood that this is how we write the expression using partial fraction. Then what we have to do is take LCM. So A will get multiplied with these two factors. B will get multiplied with these two factors and C will get multiplied with these two factors. You're going to get this. Now just tell me one thing. On the left hand side, do you see any term of x square? No ma'am, there is no term of x square. But right hand side you can see. So what are the terms of x square? Tell me ma'am. A hai, B hai, C. A plus B plus C. So that is going to be 0. Similarly, on the left hand side, is there any term of x? No ma'am. No term for x. Right hand side, can you see? Yes. What are those terms? Minus B and plus C. So minus B and plus C is equals to 0. Third option is, just tell me what is the coefficient constant term. On the left hand side, constant term is 1. On the right hand side, constant term is just minus A. So minus A and 1 will be equal. From here we got A. You plug in the value of A over here, you will get two equations in B and C. Solve it, you will get B and C. Okay. Yes, you can use log in place of ln. Do not panic about that. Okay, both are correct. So let me just give you the final answer. Can you see? Acha, this is method number 1, by the way, method 1. I have a simpler method for you, but you know what? For that simpler method, you have to think a little bit. That is a trickier to think. Ma'am, what is that method? Tell us. So let me just tell you that simple thing. The question is 1 upon x square minus 1. Okay. Integration dx. I don't know how many of you will be able to think like this. What I am going to do is, I am multiplying 2x and 2x. Can I do that? Ma'am, why are you doing this? Why? Because I will substitute x square is equals to t, so that 2x dx will become dt. Acha, okay, okay. So ma'am, you are saying by multiplying you are just trying to get 2x dx is equals to dt, right? Yes. So 2x dx is dt. So this is dt upon, now this is 2, x into x is x square. X square is t and this is t minus 1, integration. Okay, okay, 1 by 2 and this is 1 by t minus 1 dt. Okay. Now this is again a partial fraction, but the basic one, basic partial fraction, or you can just split also. So this is something, half is there na. So this is t minus 1, 1 by t. If you solve it, what will you get? T. This is correct. This is correct. Okay, integration of this dt. Now just do it right away. So half is there, log of mod of t minus 1 minus log of mod of t. Now just plus constant. Now plug in the value of t, half. Log of x square minus 1 upon x square. Mod is there, plus c. Getting it, understanding it. Which method? Sahana is saying that okay, it did. I did it first and then I was like, no, I am so dumb. Let's follow Ninja Ma'am. No, you should follow your instinct. See, in mathematics, especially in integration, there are multiple methods. That is why I am telling you multiple methods, because this, see, I cannot force someone that in exam just because in so many students will ask, how the hell on the earth I will get a dream that okay, you have to multiply 2x. Okay. Alright, so because if somebody is not able to think in that direction, then there is a set a proper method, although it is a lengthy process, but there is at least a method with which you can solve it. Okay, all right. Yes, if it wasn't live, I would have. Yes, 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 I know. See, whatever teacher says definitely influence your thoughts also. So yes, but my approach is that I just want you to think that think like this. Okay. No, we are not doing this question. We are doing another question, which is this. Similar type of question now. See, I think, see, when we do similar type of question now, then it boosts our confidence. Now, can you spot the question? Now, can you do it? Okay. Can you do it? Okay, so here also what we need to do is, first of all, x square we need to put as t. Okay, x square is t. Integral of t upon t plus 1. Integral, so you forget about integration only. Just focus on the expression t upon t plus 1 and 3t plus 4. Correct, is equals to a upon t plus 1 plus b upon 3t plus 4. Okay, all right. So now if you take LCM, your left hand side will still be a t. Right hand side a times 3t plus 4 plus b times t minus 1. Okay, so one way, acha, now there is another way also. There is another way to get the value of a and b. One way is, yes, by comparing coefficient. Can I share another method? Just think about, this is t plus 1, right? So what I'm going to do is, I'm going to put minus 1 in both the sides. Put minus 1. Put t is equals to minus 1. So t is minus 1, ma'am, minus 1 is equals to a. If this is minus 1, 4 minus 3, 1. And this is 0. So ma'am, a is coming out as minus 1. Yes. Once your a is out, similarly what you can do, now you can compare the coefficient. Just tell me that constant term on the left hand side is 0. Yes. Yes. Okay. Constant term on the right hand side is 4a plus b. 4a plus b. So this is what? B is nothing but minus 4a. So b is 4. B is coming out as 4. A is minus 1. So now just plug in the value. So this is integral of, okay, integral of a upon t plus 1. So where is a? Minus 1. Minus 1 upon t. T is what? X square plus 1. Then we are having plus 4 upon 3x square plus 4. This is dx. This is also dx. Integration. This is very easy. Tan inverse x. But what about this? What about this? You have to take 3 out of this. So 4 by 3 will be there upon x square plus 4 by 3. Okay, so now it is again same thing. So 4 by 3 now can be written down as 2 by root 3 whole square. Again same formula, tan inverse x by a. So this is minus tan inverse x plus 4 by 3 into 1 by a. So 1 upon root 3 by 2 tan inverse x upon 2 root 3 plus c. Okay. So this is how it is. This is your final answer. Okay. Minus tan inverse x, and this is what? So final answer will be what? Minus tan inverse x. If you rationalize 2 by root 3, tan inverse root 3x by 2 plus c. Getting it? Getting the type? Yes, Gauri, I remember you. Definitely. Finally, I mean, Gauri is studying since JEE days, like JEE main, we started back, beginning sessions, inequalities, we used to do logarithm, right? And then first attempt sessions, then we are having CBSE sessions. Now we'll be having second attempt session, and hopefully we will be having JEE advanced session as well, right? Oh, Gauri, are you a dropper? Then why are you here? Why are you here? So this is how it is. Done. Good question. What do you think? Okay. One more question on your way. Let's do this question. Okay, this is the last question from partial fraction, okay? Last question. I don't know about partial fraction, but definitely first step is, ma'am, now we need to substitute. My voice is lagging, you are saying, yaar, every time. This is actually going down. I need this like this. Better. I think better. What do you think? So yes, can you see? X square is equals to t. Now this time you just don't have to plug in t. Differentiate also, because 2x is already available, no? So grab the opportunity. This is all about 2x dx is equals to dt, correct? So just take it from here, 2x dx. So this is integration of dt upon t plus 1 and t plus 2 whole square. Now, ma'am, okay, so this looks like it is a problem of partial fraction, but you know what? You told us only about when there are two linear functions. When there are two linear functions in the denominator. Ma'am, there are not two linear functions here. Actually, there are one linear function and one squared function in the denominator, right? One linear and one square. So there is a different way of writing this partial fraction. The type is 1 upon t plus 1 and t plus 2 whole square, that is a upon t plus 1 plus b upon t plus 2 plus c upon t plus 2 whole square. This is how we write. Let me show you that partial fraction slide as well. Let me just show you partial fraction slide over here. Where exactly are you? Partial fraction. Are you here? Are you here? Not here, not even here. Yes. Can you see? Whenever you see that there is a x minus a whole square, so there is a square, right? So you need to write two expressions. First one will be x minus a power 1. Second one will be x minus a whole square. So suppose now if you are having x minus a whole square and x minus b. Okay, this is same category, right? So denominator will be what? X minus b term will be there. X minus a term will also be there. But x minus a square will be there. Are you getting it? Okay, so this is also important. This is also important. And this is also important. I think 1, 2 and 4. 4 things are done. 3 and 5 will come back to it little later. Okay, so just one by one start learning it. So yes, this is how it is. Now what to do? Again, ma'am, LCM. So this is A. Take LCM, t plus 2 square plus B. This is t plus 1, t plus 2 plus C, t plus 1 is nothing but just 1. Now I told you that there is a ninja technique to get the value of A, B and C. 1 is to definitely compare the coefficient, but I am not going to get into that. Just put t is equals to minus 2. If you put t is equals to minus 2, this is 0. Okay, this is also 0, right? If you put minus 2 over here, minus 2 plus 1, so minus 1. Minus c on the right hand side and 1. So value of c is right here. Okay, now put t is equals to minus 1. T is equals to minus 1, correct? So t is equals to minus 1, 1 equals 2. Now this is minus 1 if you put, this is a into 1 square. Minus 1 if you put here 0. Minus 1 here 0. So this is a is equals to 1. So you got the value of a, you got the value of c. Now is the time you should get the value of b. How to get? Put anything, na? T is equals to 0 you put. So 1 is equals to 4a. 4a is 4 into 1 plus b. Now put t is equals to 0 to 2b and plus c. C is what? Minus 1. Correct? So this is what? 2. So this is 2. 2 minus 4 minus 2. B is coming out as minus 1 again. B is also minus 1. Okay. So this is, now put the value. A is 1. So 1 upon t plus 1. B is minus 1 upon t plus 2. C is again minus 1, so minus 1 upon t plus 2 whole square. Integral. Log of mod of t plus 1 minus log of mod of t plus 2. Minus, now minus 1 upon x square integration of this will be what? Plus 1 upon t plus 2 plus constant. Okay, so this is what your answer will be. Now this is going to be log of t plus 1 upon t plus 2. T is what? X square. So x square plus 1 upon x square plus 2 and plus this is 1 upon x square plus 2 plus constant. This is the final answer, the last step. Last step will be the final answer. Okay. Yes, Athriya, you are absolutely right. I don't know how many of you are like, ma'am, yes, we are confident that we'll get the value of A, B and C. Acha, now one student is asking, ma'am, why, how are you deciding t is equals to minus 2, t is equals to minus 1? Can we put any values of t? Can anybody tell in the chat box? Can anybody tell in the chat box that why I am selecting these specific values of t? Especially these two. T is equals to 0 was just a tukka. Gauri will connect on Telegram, right? Okay. Ping me on Telegram. Chalo. How to know the value of A, B, C? Okay. Yes, you guys are writing it. Now the value of t will be such that it should give you a 0. So t minus 1 is making this factor 0. T minus 2 is making this factor 0. So that is why these two specific values. If I go back, I'll show it to you. So this was our question, right? Where is the question? Yes, this was the question. Now can you see which value of t I selected? When will this expression become 0? Ma'am, minus 1. T minus 1 will help you out. Yes? Okay, so one factor becomes 0, so that helps a lot. That is like going to reduce your question. So here, can you see, solution is already there. So we have done by t, they are doing by y. That is fine. But again, can you see, put y is equals to minus 1, minus 2 and 0. They are also doing the same thing. Okay, why they have selected minus 1? Because y plus 1 becomes 0 at minus 1. Why they have selected minus 2? Because this is becoming 0. Got it or not? Got it or not? Give me a big thumbs up, everyone, if you are getting it or not. Okay, now after partial fraction, let me just tell you, very important, which is this, integration of the type. Integration of the type. Integration of the type e power x fx plus f dash x dx. Chalo, I am not going to tell what is the final answer. You don't have to integrate such integrations. That's the best part about that. You don't have to integrate such type of format questions. Then ma'am, what? How to tackle such, if at all this part is given, then ma'am, we are not understanding. What is the answer? The answer will be just e power x f of x plus c. Okay, very important type, and we are going to solve some basic questions on this to get the hang of it. Okay, do not worry. Okay, so chalo, let's start it. Let's start it off this type. Okay, so I'll give you some time, huh? Do not worry, I'm gonna give you some time. Where is this? What is? Oh, ma'am, 2024. You have figured out a 2024 question. Okay. So basically, let me write down the formula for you right here. E power x. Okay. E power x. Okay. This is x plus x square by 2. Integral dx. First of all, answer me this. Okay, let me write down the formula. Formula is what? Formula says that e power x, f of x plus f dash x. Okay, integral dx is what? E power x, f of x plus c. Now this is a first question, elementary question, so that you just get hang of it, that how to solve such question. So first of all, you'll be like, okay ma'am, this question is having e power x. So that means that integral that you showed where direct formula is applicable, no need to integrate this actually, right? No need to integrate this. So ma'am, that means over here I need to find one function will be fx, another one will be f dash x. So if you consider this as fx, x square by 2 is fx. Can you differentiate x square by 2? If you differentiate x square by 2, you're going to get 2x upon 2x. So f dash x is this. Yes or no? That means, ma'am, yes. E power x inside the bracket, function and its derivative are there. So final answer, now that you recognize the format, you don't have to solve it. Direct formula. Once the question is recognized, no need to solve. Formula. What is the formula? Ma'am, e power x and fx, not the derivative. What is the original function? This is x square by 2 plus c. This is the answer of this question. Got it or not? Got it or not? Got it? Give me a big thumbs up if you have understood this, because if you have understood this, then only you can do this question. Then only you can do this question. Got it? Everybody? So now everybody in the chat box start solving this question, right? So obviously there is e power x. One of them will be fx, other will be f dash x. Right or wrong? Right or wrong? So just you need to just figure out which one is fx, which one is its derivative. Which one is fx, which one is derivative. So I think let's talk about this. 1 upon 1 plus x square 3 by 2. This is my function. And if I differentiate this, so this is fx, my guess. This is f dash x. If at all I'll be able to prove it, then my final answer will be what? Ma'am, e power x fx. So fx is 1 plus x square 3 by 2 plus c. This is my answer. Final answer, I am writing it. I just need to verify about this. Yes or no? If this is true, if I am able to verify it, this will be my answer. Chalo, let's do it. So this is 1 plus x square power minus 3 by 2 f of x. This is what? Minus 3 by 2, 1 plus x square. This is your, then minus 3 by 2. So this is, oh, no, not at all. No. No, this is not happening. Can you see it? So this is wrong. No. Wrong. I became over smart. This is not happening. So basically what has just happened? This is not fx. This is your fx. And this will be f dash x. Correct? So now I am putting fx is equals to x 1 plus x square minus 3 by 2. Okay, this is my fx. Now differentiate. If you differentiate, product rule. X is constant, derivative of this. So this is minus half, right? Derivative of this, can anybody tell me? Ma'am, it is 1 plus x square power minus 3 by 2. And derivative of this is 2x as well, correct? Plus sign, because product rule. This time, 1 plus x square power minus half is kept constant. Derivative of x is 1. That's it. So now what we need to do is x upon 1 plus x square power 3 by 2. Okay, so this is 2x square and this is 1 upon 1 plus x square power 1 by 2. Okay. If I take 1 plus x square out, so this is 1 upon 1 plus x square power half can, sorry, power 1 can be taken out. If at all I have taken it out, power 1. So 2x square upon, this is 1 plus x square power half. Sorry, half will be taken out, right? Only half. So this is 1 plus x square power half I have taken out. Okay, so this is what? 1. Okay, 1 plus x square, then this is plus 1. Okay, so this is 2x square plus 2 will be there kya? Let me just check the differentiation. Why are we doing product rule, bro? We have quotient rule, na? We have quotient rule. Let's do quotient rule. Quotient rule will be much easier, okay? So this is fx, right? F of x. Sorry. One more time. Please bear with me. My bad. F dash x quotient rule quickly. So this is 1 plus x square. Half ka square is this. Then root 1 plus x square is as it is. Derivative of this is 1 minus, this time x is kept constant. And the derivative of this is 1 upon 2 root 1 plus x square and 2x. 2 con. So this is going to give you what? Square root. So if you take LCM. So this is 1 plus x square minus x square upon 1 plus x square power 3 by 2. Yes. So this is nothing but, can you see now clearly? This is your f dash x. If you take this as fx, this is your f dash x. Derivative mein I took a lot of time, so sorry about it. Okay. So yes, now this is fx, this is f dash x. So answer will be what? E power x fx plus c. Okay. All right. Clear. Got the answer. Now one more question of this same type. Can we do one more question of the same type? Okay. So one more question which was asked in 2020. Now I will give you like 3 minutes to solve this question. 3 minutes. Okay. Let me come back in 3 minutes. Okay. Kichu is asking about, ma'am, anyone say why the second one is fx? No, it's not a rule. We need to figure out. So you think about it, if first one is fx, then its derivative should be the other function. We tried it. If you go and watch the recording, you will be like, I was trying. It is just a tukka, random guess that this should be fx, this should be f dash x, right? So if it is not working out, then you have to change, right? So let me just give you this again. E raised to power x is there, that is why. So just multiply it right away. So we can see that there are two things, this and this, two terms. E power x, then this is what? 1 upon x plus 1 plus x plus 1 gone. This is log of x plus 1. Okay. All right. Now, just tell me, what is your function? Which is your fx? This is your fx. This is your f dash x, right? Because log x plus 1 derivative is 1 upon x plus 1. So if this is fx, your answer will be what? E power x log of x plus 1 plus c. Okay. So option D is absolutely right. Option D is absolutely right. Easy question. What do you think? Everybody is getting it now? Everybody, I think, is getting it. Previous question was a little bit tricky, but with this question, at least the concept is clear. One more question. Are we ready? Let's do one more question. Okay. So this is that question, 2020. Similar type of question. I'm gonna give you like 1 minute. I'll come back. I'll get some water. I'll come back. I'm back. Okay. Yes. So again, the same type of problem, right? E power x, e power x. This is what? Log x plus 1 by x. Integration, dx. Okay. All right. Done. Now just tell me, this is your function, this is its derivative. Answer will be e power log x plus c, option D. Everybody? Yes. Done. Okay, now one more question with a little bit twist. Let's see how many of you are able to handle this. Ma'am need case based session. Array, have you not seen my क्या बोलते schedule? Everybody has seen my schedule, right? Okay. If not, just go and watch that schedule. 5 days planner I have shared on Telegram, on Telegram also, and on community post also, wherein everything will be covered. MCQ, 2 marker, 3 marker, 4 marker, case study based, assertion, reason, everything. Now E is missing. Everybody is complaining, ma'am, where is E? Where has E gone? Where has E gone? Where has E gone? So they give you a little bit twist and you'll be like, ma'am, we are not able to do that. Tell me what to do. Okay. Let's do one thing. Integration of, let's separate it out first. 1 upon log of x. Not separate it out. Let's do one thing. Let's put log x equals to t. If log x is t, tell me one thing, that e power t will be equals to x. Yes. So dx will be equals to what? E power t dt, correct? So dx will be replaced by e power t dt. Correct? This is your dx. Okay, ma'am? E power t dt. Correct? Log x minus 3. So log x minus 3 will be what? T minus 3 upon t power 4. Now can you see e power t? Now can you see e power t? Everybody, visible? Huh? So now you do it now. E power t. This is 1 upon t cube. This is minus 3 upon t power 4 and dt integration. Now just tell me one thing. This is your t power minus 3 is your function, suppose. So the derivative will be minus 3 t power minus 4. This is f dash x, which is minus 3 by t power 4. This is your f dash x. So with sign, can you see if I apply plus sign and minus sign? So if this is your fx, can I write this as f dash x? Yes, ma'am. So now the answer will be what? E power, t, this is t. E power t 1 by t cube plus c. Now e power t will be what? X upon t cube. So log of x whole cube plus c. Okay. Yes, correct. Got it. Clear. Any doubts? Any confusion? Now can you see e power t? Good question. What do you say? Good or not? X upon log cube you are saying. X upon log cube. What are you saying? X upon log x cube. So this is the answer, okay? Now what I'm going to do is I'm going to take you to again the formula revision, which we have already done, by the way. Formula revision, let's do dx upon x square minus a square. So this is a very important formula. This type will definitely be there. 1 upon 2a log x minus a upon x plus a. Then dx upon a square minus x square. 1 upon 2a log a plus x upon a minus x. Dx upon x square plus a square, 1 by a tan inverse x by a. Okay. All right. Clear. Now some more integration. I have already told you the sine inverse one is not having 1 by a. Now these two integrations. Yes, these two integrations, remember, copy paste integrations. Dx upon a square plus x square root, dx upon x square minus a square root. So log x plus copy paste, log x plus copy paste. Together remember this. Okay, remember this together. Now if I talk about integral of x square minus a square. So can you see this and this are same only. It's just that this is in denominator, this is in numerator. Okay. So one thing which you can see that this part is absolutely same, log x plus square root x square minus a square. Correct? And this is x by 2 square root x square minus a square minus. So this part you have to remember, rest half is already there, a square by 2, please do not forget. Same with this. Square root a square plus x square again same. So here plus sign overall x by 2 copy paste plus a square by 2 log x plus copy paste. And this is your square root a square minus x square. Can you see this and this has some correlation? This is in denominator, this is in numerator. That is why sign inverse will be there. This is a trick to remember. X by 2 copy paste plus a square by 2 sin inverse x by a. Okay. So just write down all the formulas. Although I'm going to take a formula revision session guys on 8th March 5 o'clock in the morning. So I'm going to revise you everything. I'm going to tell you the trick at one place. But right now just keep remembering whatever you can remember. Okay. And keep applying also. So ma'am, why are you actually focusing on remembering formulas so much? Because of such questions. Because of such questions. Dx upon square root 2x minus x square. So integral of dx upon square root. Now can you see 2x minus x square? So this is what? Tell me. This is your quadratic. So you have to make it perfect square. Now how come? So let me tell you. You take minus sign common. So this is minus sign common. X square minus 2x. Okay. Now you know that x square minus 2x. If I add 1 to it, I am going to get x minus 1 whole square. Okay. Alright. So dx upon square root. Now if you add plus 1, okay. So if you add, see. So this is minus, so basically you have to subtract 1. Or what we can do is directly subtract 1. So 2x minus x square minus 1 plus 1. So this is a perfect square. Okay, and the negative ka perfect square. So this is 1 square minus x minus 1 square. Yes or no? So this is actually matching with dx upon square root a square minus x square integral. Remember what is the formula? Can anybody tell what is the formula? So formula is sine inverse x by a. So this is sine inverse x by a plus c. Easy peasy lemon squeezy. Oh yes, Athriya is writing, Vivid is writing. What do you think? Everybody else? Are you getting it, understanding it? How to tackle when there is 1 upon square root of quadratic. Or in fact, you can have 1 upon quadratic. How to tackle it? 1 upon quadratic. Tell me. 1 upon quadratic. 1 upon quadratic will be integration of dx upon x minus 3 whole square. Do you know how to make a perfect square? Minus 9 plus 13. Let me show it to you. If you at all you're not aware, ma'am, how to make a perfect square. So just understand that step by step. X square ka I'm going to write x. Square I'm going to remove. Minus sign I'm going to copy paste. There is the 6, right? 6 divided by 2 is 3. This is whole square. Now there is this fixed minus sign. Fixed. No matter what, this minus sign will remain minus even if you come after 500 years. Okay? I'll be standing here. This minus sign will remain minus sign after 500 years also. Then you are having 3 squares. Square of 3. What is square of 3, ma'am? 9. And that's it. So this is replaced by this. Just open it. You will get this. Plus 13. You just need to copy paste. Okay? Alright. Clear? So this is dx upon x minus 3 whole square. 13 minus 1 is minus 2. So plus 2 square integral. Which formula is this? Which formula is this? Now I'm not going to tell you. No. You are going to tell me. Don't you think? Do you get deja vu? 1 upon x square plus a square is nothing but, by the way, you have to write it. Okay, so this is 1 by a tan inverse x by a. One more. Are we ready for one more? Okay. Now there is a little bit difficulty. So now, ma'am, how to make perfect square, because there is a 5 over here. So 5, let us not do it over here, because here if I am going to do it, it will look very messy. Let's take this 5x square minus 2x. Let's give it some time. Step by step, okay? Step by step we are going to do. Take 5 common. Okay, ma'am. 5 is taken common. Now just apply that. Apply that same thing. 5 is outside. So this is x square. X square will be written down as x. I have removed the square. Correct? X. Minus sign is copy paste. This is not fixed minus sign. I am just copying and pasting. If it would have positive sign, I would have written positive. Now 2x by 5 is divided by 2 is what? 1 by 5 whole square, and there is this fixed minus sign which is still there since 1600 AD or BC, before Christ. Okay, and even after 5,000, 10,000 years, this minus sign, you will see it right here. I'll be standing here and you'll be like, ma'am, minus sign is still there. And this is 1 by 25 and bracket close. You multiply 5. Okay, that's it. 5, no need to multiply. That's it. Okay. All right, clear? Now this is what? Integration of dx. Square root of, same setting. I'm going to do it inside. Just put the value. X minus 1 by 5 square. And this is minus 1 by 5 square. So 1 upon root 5 integral dx upon x minus 1 by 5 whole square minus 1 by 5 whole square, square root. This is now integration of 1 upon square root of x square minus a square. Tell me. Log of x plus copy paste. Remember, log of mod of x plus copy paste. Log of mod of x plus copy paste, correct? So this is also 1 by root 5 will remain outside. Log of mod of x. X is this plus copy paste. So copy paste means what? This is the copy paste. Square root x square. So this is x square minus 2 by 5x. Okay. Modulus close plus constant. Yes or no? This is the final answer. Are you remembering now? You maybe you're getting the ma'am. Okay. Now see, once you see the formula, if you not apply that now, you will not get the confidence. Understand? At least one question on each formula if you do, then only you'll be like, okay ma'am, I am able to get the confidence. Okay. All right. Are we ready for the next category? Next category. What is the next category? Okay, let me just bring you to the next category, which is this. This is a different category. Okay, what is this different category? Hello, hello, hello. Voice is low. Volume. Acha. Let me just check my volume. Volume is full. Volume is full. System's volume is full. And let me check whether there is any filter on it. No filter also. The volume is full. Why do you guys complain about the volume? Chalo. Yeah, I think so many of you already know. Yes. These guys are writing. Whenever you see linear upon quadratic, or linear by root quadratic, linear upon quadratic, linear by root quadratic, then what to do? So you have to write the numerator is equals to derivative of denominator plus a times derivative of denominator plus b. Understand what I'm trying to say? Yes. So whenever there is linear upon quadratic, so you can say that, or rather you can say that quadratic, sorry, not quadratic, linear is equals to a times derivative of quadratic plus b. Okay. Linear is equals to a times derivative of quadratic plus b. Ma'am, what is linear? 3x plus 5. A is right there. Derivative of quadratic, only quadratic. 2x plus 2 is derivative of quadratic plus b. This is how you need to write this. So 3x plus 5 will be written down as this. Okay, ma'am. Hold on one by one. Now what we can do is just compare the coefficients. Coefficient of x is 3 on the right hand side and this is 2a on the left hand side. 5 is equals to 2a plus b. Okay. So from here a is coming 3 by 2 and b is coming what? 2. B is 2. B is 2, right? A is 3 by 2, B is 2, correct? So now what we are going to do is 3x plus 5 can be written down as what? Tell me. 3 by 2 into 2x plus 5 plus 2x plus 2. Plus b is what? 2. Yes or not? Getting it? So this whole integration will become what? 3x plus 5, I am replacing it right now. 3 by 2, 2x plus 2 upon square root x square plus 2x plus 4 plus 2 upon square root of x square plus 2x plus 4. Okay, all right. Tell me honestly, bachcho, first of all, you are not liking my session. This session I have so many less likes. I don't know why. Okay, that is one thing. Second thing will be, are you guys not hearing my voice? Is it very low? Is it low? Do you want me to experiment? This is for CBSE, okay? So this is the integration. By now you must have understood it. So this is I1 and this is I2. Separately I am going to talk about I1 and I2. So first of all I1, which is what? I1 will be, tell me, 3 by 2, correct? 3 by 2, yes. I1 will be 3 by 2, 2x plus 2 upon square root of x square plus 2x, what was the question? Plus 4. Plus b times, this is b times 2, so this is I1, that's it. I1 dx integral. Now I am going to take this as t. So this is x square plus 2x plus 4 now is t. Now the question will be done. Okay, so 2x plus 2 dx will become dt. So this thing is dt and this is root t. So I1 will be equals to 3 by 2 root t, and this is dt. Okay. So 1 by 2 root t integral. Okay. So 3 by 2 t power minus half plus 1. So this is root t and 1 by 2 plus c. Half and half cancel. I1 is equals to 3 square root of x square plus 2x plus 2 plus constant of integration. This is your I1. I1 is sorted. Yes or no? I1 integration. Okay. 3 times this. What about I2 now? What about I2? So I2 is, let me take over here I2. I2 is what? This. 2 upon square root of x square plus 2x plus 2. Now understand that this is the question wherein just constant upon square root quadratic is there. Now this you have to make it perfect square. Remember, we are doing this question since so many, like couple of minutes. Same. This is 2 upon square root x plus 1 whole square plus 1 integration dx, and this is going to give you I2. Okay. This is 1 upon x square plus a square. So what is the formula for it? So formula for it will be log of mod of x plus copy paste. So this is your I2. Okay, let's not forget 2 is already there. This is I1, this is I2. If you add these two integrals, you'll be like done. We'll take a break. I think applications of integral, we need to take one session for application of integral, right? Okay, so let's do one thing. I don't know what's wrong with this. Let me remove. Is it better? Or same? Or shall I switch to Acha? Let me just switch to another mic. Okay, just tell me that is it any better? Another mic. No, AOD I have not taken. Another mic. So this I have not used. Better. Same voice. This is the maximum voice. Same. This is the maximum voice. It's better I should switch to that collar mic only. Better. One student is saying, there is actually no problem with your voice, ma'am. Acha. Your voice is good only. Some students are saying that clear, absolutely clear. So see, this question we have done, right? Let me just tell you a brief about it, because a 2024 question, linear upon quadratic. Linear upon quadratic, mein what we need to do is, this linear will be equal to a times derivative of quadratic plus b. Correct? Now just compare and get the value of a and b. So a is 3 by 2 and b is 2. Correct? Okay, so yeah, here 3x plus 5 will be 3 by 2 into this plus 2. So now your expression has become this. 3 by 2, 2x plus 2 upon this is your basically, so you're writing 3x plus 5 is what? A times. So 3 by 2 times 2x plus 2 and plus 2 times 1. That's it. So upon there is square root. So upon square root upon square root. So this is integral number 1, integral number 2. Got it? Now from here just put this as t. Substitute this as t. So substitute this as t. So this will be dt. Correct? So dt by root t you can integrate. What about this? Make perfect square out of it. So you're going to get this. So this is 4. I just think ki I have not written 4 over here. No? This is 4. So this is 3. This only is 3. Yeah, better. So final answer you can see on your screen right away. Clear? Okay. Now I am going to move towards definite integration. Definite integration, yes. Yes, we are going to take such questions also if one student is writing. Okay, so such questions also will be taken. Definite integration. Do you want me to take? Ma'am, that system mic is good. Okay. Let's take a 10 minutes quick break. What do you think? 10 minutes quick break will do. By parts will do. Switch to another mic, you're saying. What is wrong with this mic? That is good, no? So let's take a quick break. What do you think? It's 15:40. Let's come back at let's say 3:55. Okay. Okay. All right. Better. Chalo. Definite integration, are we ready? Are we ready, students? Definite integration. Let's do a couple of questions, right? Okay. All right. Come back. Definite integration. So over here, this is the question 2023. Okay, 2023. Sorry. My bad. I got late. Okay. Chalo. 2023 minus 1 to 1. Can you see this? Okay. So over here minus 1 to 1. Correct. So what I'm going to do is I'm going to break this limit. Yes. That's how we do. Okay. So let me just revise you. So first property says that, okay, so this is, just tell me one thing, that x minus 2 mod x minus 2 is equals to x minus 2 when x is greater than or equals to 2 and minus x minus 2 when x is less than 2. Yes or no? Here can you see the upper and lower limit minus 1 and 1, minus 1 to 1 basically. Minus 1 to 1, this interval is less than 2. Yes or no? This interval is less than, what do you say? Less than 2. So that means now mod of x minus 2 will become minus x minus 2 upon x minus 2. This is gone, integration minus 1 to 1. So minus 1, okay, dx integral minus 1 to 1 will be what? So minus x, upper limit and lower limit. Now it is going to be minus 1, minus. So final answer will be what? Option D. Everybody, what do you think? Final option will be what? Option D. This was an MCQ in 2023. How many of you are getting it? How many of you are getting it? JEE PYQ series super soon we are going to start right after the board examination, right? One more question from 2023 MCQ. Let's see how many of you are able to do it. Yes, this question 0 to 4 e power 2x plus x dx. Integrate e power 2x. Integral of e power 2x is ma'am e power 2x upon 2 plus this is 1. Now this is 0 to 4. Correct? Integration of x is what? Integration of x is x square by 2. So this is now e power 4 by 2 plus 4 by 2 minus, if you put 0 over here, so 1 by 2 plus 0. So correct answer will be e power 4 by 2, e power not 4, e power 8. So e power 8 by 2, correct? E power 8 by 2 plus 3 by 2. Oops, I am doing something wrong. Put the limit again. Oops. E power 8 by 2 plus 16 by 2 minus, if you put 0, 1 by 2. So this is e power 8 plus 15 by 2. Option A. Easy peasy, right? Easy peasy question. One more question on your screen. Now let's see. This is my favorite question. I have taken this question in last year also. This is my favorite question. Let's see how many of you are able to do it, because I am going to give you some time to do it. Time to think. Okay, time to think. So, over here again, so these type of integrations are just like your indefinite integration. We have done a couple of questions from indefinite integration, right? So indefinite integration we have done, right? Now the same thing without any properties or all, basic question, just you have to put upper and lower limit. Okay, so this is tan inverse 1 by 2 tan inverse x by a. Remember this formula, tan inverse x by a, 1 by a is equals to 1 upon, this is the formula, 1 upon x square plus a square integral dx plus c. Okay, so this is how it is. A is what? 2. Now this is 0 to a. Put a, half tan inverse a by 2 minus 0. Okay, this is equals to pi by 8. Clearly if you cancel the terms out, 2 ones are 2 fours are, tan inverse a by 2 is pi by 4. So clearly this a by 2 should be equals to 1. This implies a is equals to 2. 2, 2, 2. So answer is a is equals to 2. 2014 question. Okay, so 1 mark may you can get this, or in 2 marks also you can get this, right? Okay. Now one property. Which property? So yes, let me just talk about a couple of properties of definite integration. Property number 1 is what? Tell me. So 0 to a, or you can just say a to b. A to b f of x dx is equals to a to b f of t dt. That means in definite integration specifically, definite integration, if I talk about definite integration, specifically definite integration, you can change the variable at any given point. If it is x, you can change it to t, you can change it to y, but not in indefinite. Indefinite means it's not allowed. Only indefinite. Why ma'am? Why indefinite? Because understand that definite integration is always a constant value. It doesn't matter you integrate with respect to x or t. Are you getting my point? First property clear? Second property of definite integration, properties are really important. Second is, suppose you have to integrate 1 to 3 any function fx dx. But you already know that the function is changing its definition about x equals to 2 in between. 1 to 3. It happens now sometimes, suppose I have to go to, there is a town in Bangalore, like nearby Bangalore. What is the town? Tumkur. I have to reach Tumkur. But there is no direct way to reaching to Tumkur. What can I do? I can take a flight from Indore to Bangalore. And then after Bangalore, I can travel via bus or my car. Okay? Same thing happening over here. If I want to go from Bangalore to Tumkur, Indore to Tumkur, I can take a stop in Bangalore. Can you see? So, Indore to Bangalore, Bangalore to Tumkur. Can I do that? Okay. But why am I taking that stop? Because I need to stop at Bangalore. Here also, why am I stopping at x equals to 2? Because my function is changing its behavior at x equals to 2. Okay, alright, getting it? This is the second property. What is the third property? King's property, which says that if a to b f of x dx is there, now your x, only this x will be replaced by f of a plus b minus x dx integral a to b. This is your King's property. Okay, and this King property has a specific type where your upper limit, your lower limit becomes 0, upper limit becomes a f of x dx, f of a minus x dx 0 to a. 0 to a. Can you see this? Yes? Alright. Third property. So, 3 more properties we have learnt. Change of variable. Okay. Breaking of function and King's property. Okay. Now, we are going to utilize this. Let's utilize this. This was a question which was asked in 2020 CBSE. Okay, now King's property, why is the name King's property? Can anybody tell? Because majority of the question is all about King's property. And how to use King's property, that we are going to learn in this particular question. Okay, so always remember, trick to use King's property. Trick to use King's property. What is that trick? Apply King's property and add. Apply King's and add. Always remember that what will happen? Denominator should be same. Okay. Let me tell you. Let me show it to you what I'm trying to say. Let me execute it for you. Okay, trick to use King's property. This is the integral which is given to you. 0 to 1 tan inverse 1 minus 2x 1 plus x minus x square dx. Now King's property says, let me write the King's property. 0 to a f of x dx is equals to f of a minus x dx 0 to a. That means I am replacing this x by a minus x. So here I am going to replace my x by 1 minus x, yes or no? So this is my integral I, this is my first equation. Now if I just replace x by 1 minus x, so your integral will become what? Tan inverse 1 minus 2 1 minus x upon 1 plus 1 minus x minus 1 minus x whole square dx. Okay, if you solve it, what will you get? 1 minus 2, so minus 1, right? And then plus 2x, so 2x minus 1, and we are going to have 1 plus 1, 2 minus x, and this is plus, sorry, minus 1 minus x square plus 2x. Okay, this is tan inverse integral 0 to 1. If you solve this, what will you get? Tan inverse 2x minus 1. By the way, this 2x minus 1 can also be written down as minus 1 minus 2x. Upon, what about this? This is minus x square. 2x minus x will be plus x. 2 minus 1 will be 1. This is integral 0 to 1 dx. Can you see clearly that? Understand. First of all, what did we do? Trick to use King's property, right? Apply King's property and add. So first of all, I just did one thing. I have just applied King's property and I have just solved it. Can you see? This was my original and this was my after King's property. This is the second equation. This is also I equals to. This is my second equation, right? Now, if you see this and this, after applying King's property, you will realize the denominator. Even after applying King's property, can you see? The denominator is becoming same. Denominator should become same. If it is not becoming same, you are wrong. There is something wrong with you. Okay? Alright? Alright? So, clearly now if I add these two, integration is what? 0 to 1 tan inverse 1 minus 2x upon 1 minus x plus x square. This is what is there, right? Tan inverse के अंदर है. And this is I 0 to 1 tan inverse. This is negative, so negative will come out. Tan inverse minus something, it's minus tan inverse 1 minus 2x 1 minus x. Okay, this is your second equation. First equation. Now if you are going to add 2y is equals to plus minus 0. Integration will be a big fat 0. That is how your King's rule will become. Okay. Alright. Clear? Yes? Shall we talk about the next couple of properties now? Next property is your even-odd property. Even-odd property. Even-odd property says that suppose minus a to a, your fx is there. This is going to be 0 if fx is odd. Now, what is an odd function? How to determine whether this function is odd or not, right? So, an odd function is that function which satisfy this particular equation. F of minus x is becoming minus f of x. Okay? Perfect. Okay. Even odd property. Now, if I talk about a function being even function, so this is twice of 0 to 2 f of x dx. What is the definition of even function, ma'am? F of minus x is going to be f of x. That is going to be even function. That is going to be even function. Alright? Okay. So let's do one thing. Let's tackle this question first of all. So this is a similar type. Just tell me, can you say that this is an even function or odd function? By the way, it is not necessarily. It is not necessary that a function has to be either odd or even. Okay, it is not necessary. So don't unnecessarily just try to prove, bring any function out. You have to be either even or odd. Tell me whether you are even or odd. So you'll be like, no bro, I am neither even nor odd. Remember? Okay. So these days, you know that LGBTQ. Neither this nor that. There is something new. NENO. Okay. So even is a male, odd is a female. Neither even nor odd functions are called as, you name it. I'm not going to do that. Okay. Alright. Okay, so there is a third, like there are not only just two options, that male, female. No, others. You can tick others also, others checkbox. Okay, so just like that. So this is an even function, but this is an even function. So if this is an even function, so minus 2 to 2, 4x power 4 minus x square plus 1 dx is going to be twice of 0 to 2, 4x power 4 minus x square plus 1 dx. This is an even function. Now you can peacefully integrate it. So this is 4x power 5 by 5 minus x cube by 3 plus x. This is 0 to 2. So this is 2. And now we are going to have 32 into 4. 32 into 4. Now do the calculation. Calculations you will do. So answer would be what? 748. So it is 748 by 15. Okay, just plug in the value. Upper limit 2 minus lower limit. But understand that you have to write the property. First of all, let us assume this. Okay, fx, let fx is equals to 4x power 4 minus x square plus 1. F of minus x is also 4x power 4 minus x square plus 1. Hence, fx is an even function. Now for an even function, we know the property minus a to a f of x dx is equals to twice 0 to a f of x dx. Understood? Getting it? Okay. Virendran, that's what? Ma'am, how to find it is even or not? That is how you find. You have fx, function is this. You calculate f of minus x. So you put x is equals to minus x. X will be replaced by minus x. And then you realize that even if I replace x by minus x, my function is coming same. If the function is coming same, then this is an even function. Okay? Got it? Yes or no? Clear? Everybody? Okay. Chalo. Now next question, I am just going to open the next question and I'm going to stay quiet. I'm going to stay quiet. Okay, so this is an odd function. Let us assume that f of x is equals to x power 5 plus sine x, correct? f of minus x is going to be minus x power 5 minus sin x. If you replace x by minus x, you will realize minus sign will come out. Sin minus x is also minus sin x. So this is clearly an odd function, and the property says minus a to a f of x dx is equals to 0 if fx is an odd function. Okay. All right. Clear? Yes. Perfect. Perfect. A couple of more questions related to substitution. Basic substitution, just like your indefinite integration, right? Just like your indefinite integration. Let's do it. Let's do it. Okay. Chalo, let's do it. Substitution by definite integration, you can see sine root x by root x. Sine root x by root x. Yes, is it always 0 if it's odd? Yes, yes, that's the property. You didn't even see the property. Kya? Was I very fast? Just tell me. This was the property, right? Minus a to a fx dx is 0 if my function is odd. Minus a to a fx dx is twice of 0 to a. This is twice of 0 to a. Okay, so if my function is even. Okay, so this is the property I was talking about. Chalo, let's do this question. 0 to pi square by 4 sine root x by root x. So let's take. Now substitution basics. Root x. In substitution, especially in case of definite integration, do not forget to change the limit, because that is going to be game changer. Root x being t. Correct? X is equals to t square. So dx will be what? 2t dt. Correct? So this dx will be replaced by 2t dt. Sine root x will be sine t upon this root x is again t. So over here but. Now limits are going to get changed. It is not going to be 0 to pi by 4. So upper limit. Original upper limit in the question is pi square by 4. So t will be root x. That is going to be root pi square by 4. So t will be pi by 2. That is your upper limit. So upper limit is pi by 2. What about lower limit? Lower limit, if I talk about, x equals to 0. So if you put x equals to 0 over here, t is also going to be 0. So this is it. Now start cancelling t. So integration of sine t is minus cos t. Upper and 2 is already there. Upper limit, lower limit. If you put, so 0 minus 1, that's it. So 2 is the correct answer. 2 is the correct answer. Correct or not? 2 is absolutely right. Okay, alright, clear. Next question, similar type. Got it? Similar type. Let's see. Again, now what should I substitute? Can anybody tell me? I should substitute, I think 1 minus 4t cube is equals to x. So minus 12t square dt is equals to dx. Yes or no? Yes or no? So minus 2 to 0, 2t square. So 2t square. So understand this is 2t square dt is equals to dx upon minus 6. So dt and 2t square will be gone and will be replaced by dx and minus 1 by 6. What about this? This is square root of x. That's it. Okay, so minus 1 by 6 minus 2 to 0. Integration of, oops. I made the same mistake which I was warning you about. Okay, so this is what? Minus 1 by 6 and this is dx and this is root t. But limits are going to get changed. Okay. So what is upper limit, ma'am? T is equals to 0 is the original limit. Put t is equals to 0 over here. You will get x equals to 1. So x equals to 1. This is root x, right? Not root t, but root x. If you put t is equals to minus 2 over here, if you put minus 2, 1 plus 8 fours are 32 is equals to x. This is your lower limit. Okay, so 33. Correct or not? Now let's integrate. The integration of this is x power 3 by 2 upon 3 by 2 minus 1 by 6 is already there. Okay. Upper and lower limit 33 and 1. Okay. If you put 1 right here, what you're going to get is minus 1 by 6. Okay. Let's do one thing. This is 2. So minus 1 by 9 and there will be 1. That's it. Plus, now put 33, so 1 by 9 into what is this? 33 raised to power 3 by 2. So, correct answer will be 1 by 9, 33 root 33 minus 1. This is the correct answer. Someone is screaming, you are saying, yeah, some sabzi wala. This is the correct answer. Yes, Santosh is asking how 2 and minus 6. How 2 and minus 6. See, minus 12 can be written down as 2 into minus 6. 2 I am keeping it here, minus 6 sending down. Work or not? It works or not? Give me a big thumbs up. Okay. Chalo, let's do one more question on substitution. One more question on substitution. So, sin x is equals to t. If sin x, you have to substitute sin x as t. If sin x is t, just tell me about the upper and lower limit. Let us calculate upper and lower limit once. Okay. Okay. Sin x is being t. So, just tell me, obviously cos x dx will be equals to dt. Cos x dx. So this is dt and this is cos of t. Cos t dt. Correct? Upper and lower limit. So when you put minus pi, sin minus pi is 0. When you put pi by 2, you are going to get 1. That's it. A very easy. Integration of cos is what? Minus plus sin 0 to 1. So this is sin 1 minus sin 0. Correct answer is sin 1. Sin 1 is the correct answer. Got it or not? Okay. Sin 1 correct. Now, we are having a couple of questions on this property where we need to break the function. Remember that break Bangalore, Indore to Bangalore, Bangalore to Tumkur. What is so special in Bangalore? Because the definition is getting changed. So, here we need to integrate this function from minus 1 to 1. But can you just spot where exactly your definition is getting changed, ma'am, at x equals to 0. So, you need to break minus 1 to 0, ma'am, and then 0 to 1. So, this thing you have to calculate. This can be written down as this. Okay. I always share the session PDF, especially like I give it to my team so that they can update the description box, but I share the PDF in Telegram as well personally. So Vedantu J English official Telegram channel I am going to share. Do not worry, I am worried about you more than you. Each and every PDF within 10 minutes you will get after the session is over. Okay. Be assured and peacefully relaxed mindset say you just attend this session, and you know what, don't take stress. Just you have time. In mathematics you have a long gap. Yes or no? Do you agree or not? You have long gap. So you can do one by one chapter in detail, NCERT, PYQs, exemplar, all the questions you can do. You can attend marathon, you can do my PDF also. Right? So this is how it is. So now just that minus 1 to 0 fx. So minus 1 to 0, that means x less than 0. So this fx is what? 1 minus 2x. 1 minus 2x dx minus 1 to 0 plus 0 to 1, 1 plus 2x dx. Correct? So this is x minus, what is this? 2x, correct? So this is x square. Now put minus 1 and 0 plus. This is x plus x square. Put 0 and 1. Now satisfy. Upper limit will gonna get you 0 minus lower limit minus 1 and this is minus 1 plus this is 1 plus 1 minus 0. Final answer will be what? 2 plus 2, 4, 4, 4. 4, 4, 4. Okay. 4 is the correct answer. I think everybody over here got this answer. Yes? Okay. Clear? Next question, let me move on to the next problem. There is a student, Jewel Baiju. He has a very innocent question he is asking. He is saying, ma'am, what if I substitute something else in the examination and I get completely different answer? Then what? That must be you have done something wrong in the solution. Okay? Even if your method is different, your answer should be same. There must be something wrong. Okay? So do not worry about it. It happens that ma'am is getting 2.5 and I am getting Prithviraj Chauhan as the answer. It happens or not? Ma'am attending this session? Yes, trust me. NCERT, by the way, I'm gonna give you NCERT important questions also. Today, shall we reveal? Okay. So NCERT important questions of all the, what do we say? All book number 1, book number 2, all the like 1.1, 1.2, 1.3 like that. So all the questions I'm gonna give. Okay. So you can do NCERT. PYQs we are doing session wise also. Then 200 plus PYQs also I am giving it to you. Okay. Right. Okay, alright. Give me some time, like I have it ready by tonight or tomorrow morning. Maximum I am going to share the NCERT important questions, right? Let's do another question, 0 to 1 mod fx minus 3. Okay, so 0 to 1 mod fx minus 3. So clearly that 5x minus 3 modulus is 5x minus 3. X is greater than or equals to 3 by 5. And minus of 5x minus 3, x is less than 3 by 5. Okay? Alright? Clear? Perfect. Now understand 0 to 1. The function is changing its definition at 3 by 5. So 0 to 3 by 5, that is less than 3 by 5. You want 3 minus 5x integration. Plus this time 3 by 5 to 1, 5x minus 3 dx. Okay, so this is 3x minus 5x square by 2 plus 5x square by 2 minus 3x. Upper and lower limit, this is what? 3 by 5 to 1 and this is what? 0 to 3 by 5. Start putting the values over here. You put 3 3 is 9 by 5 minus this is 5 into 9 by 25 by 2. So 9 by 10. So this is 9 by 10. 0 pe we are going to get 0 plus. What about this? Now put 1 5 by 2 minus 3 and minus sign you put 3 by 5. So you are going to get, if you put 3 by 5, you are going to get again 9 by 10 or 3 by 5 if you put 3 3 is a 9. So minus 9 by 5. Perfect. So just understand 9 by 5 plus 9 by 5 will become 18 by 5. 9 by 10, 9 by 10 minus what? 18 by 10. Plus, this is what? Not plus. This is minus 1 by 2. So this is 18 minus 9. 9 by 5 minus 1 by 2. This is nothing but 10. 18 minus 5 is 13. 13 by 10. 13 by 10. Can you check whether Ninja Ma'am has done? 13 by 10 it is. 5 by 2 minus 3 done now. This is what? 3 to the 6 minus half. Okay, everything is right there. You do your calculation. Okay. You do your calculation. You'll get the answer. One more question can we do? Session will get over approximately 5:15. Acha, students, let's do one thing. I think we are in short of time. So what we can do is, we can just focus on integration today. What I'm going to do is, I'm going to record a video of application of derivatives and differential equation in the night tonight, and I'm going to upload this video tomorrow morning, because we need to do MCQ short session also now. So let's start the MCQ at 6. So before 5:20 we are going to done with that. Okay, so let's take like half an hour break. 6 o'clock, let's start. 6 to 8, 8:30 will be done. Okay, and then tomorrow I can give you application of derivatives and differential equation. And tomorrow we have 2 o'clock, we have class also. Okay, let's do this. Okay, by tomorrow 100% I'm gonna give you. Okay, either I'm gonna take class at 11 or I'm gonna give the video. Tonight I'm gonna record. Okay, all right. Billionaire, don't get scared. Application of integration and that area plus differential equation, 2 topics I'm gonna give you in a separate video. Ma'am, plus half is coming. No, why plus half? 3 to the 6. 5 minus 6 is minus half. Now 13 by 10 is the correct answer. See, 13 by 10. Okay, all right. Now we are having this question. By the way, this question partially I'm gonna do, partially I'm gonna give you homework. Okay, so I'm gonna tell you that how exactly you have to do. So let us treat this as 2 different integration. So 1 to 4 mod x dx plus 1 to 4 this. Okay, all right. So mod x, understand, mod x will become x when x is positive. So here x is 1 to 4, that is positive. So x dx 1 to 4. But this, can you see, mod of 3 minus x. So if I talk about mod 3 minus x, it is going to give you 3 minus x when x is greater than or equals to 3, x minus 3 when x is less than 3. Sorry. Okay, so 3 minus x, correct, mod of 3 minus x. Now understand, we are going to break this limit at 3. 1 to 3 plus 3 to 4. Now 1 to 3. Between 1 to 3, what is happening? 3 minus x dx. Between 3 to 4, what is happening? X minus 3 dx. Okay, so now this is x square by 2, 1 and 4 plus 3x minus x square, 1 and 3 plus x square minus 3x, 3 and 4. 4 4 is 16, 16 by 2 is 8 minus 1 by 2 plus, put the value, 3 3 is 9 minus, this is 9, 0, minus, if you put 1, 3 minus 1, 2 plus, if you put 16 minus 3 4 is 12, minus you have 9 minus 9, which is 0. So final answer, can anybody tell me? This is 0, this is 0. So this is what? 8 minus 2 is 6. 6, and what about this? 4. 6 plus 4, 10. 10 minus half will be the answer. So this is 19 by 2. Yes? No? (16 minus 1 by 2). 15 by 2, correct? So this half is something which is, sorry, 2 is missing. No, upon 2, I just forgot upon 2. Sorry. So this is 9 minus 9 by 2. This is to gone. Now I think. What about this? If you put 3 minus half. So this is 3 minus half. What about this? 3 minus half. And this is 4 4s are 6. So this is 8. Okay. This is 1. 3 minus half. Correct. So half and half being cancelled out. So this is 8 plus 8 16. And we have 16. 8 plus 8 16. Minus 3. 16 minus 3 is what? 13. Hold on. 8 minus 4. 4 plus, where is 6? 8, 12. 3 by 2, 9 by 2 minus 1. So this we need to add. This is going to be plus. This is not getting cancelled out. So answer will be 9. Okay. So 8 plus 9. 8 plus 9 minus 3 minus 4. So this is our total 17 minus 7. 10 will be the answer. 10, 10, 10. 10, 10, 10, 10, 10. 10, 10, 10. Yes. Integrals 1 to 3. Correct? Got it, got it. Okay. Alright. Clear? Now some questions let's do. Some more questions we are going to do on King's property, based on King's property. Okay? Ready? AOD word problems we are going to do in 200 plus PYQs. Okay? 200 plus PYQs. Stay tuned for that. Okay. So this is King's property problem. I told you that how to apply King's property. First of all, integration is 1 to 2 root x upon root 3 minus x plus root x dx. Okay. So now if you apply King's property, you need to replace x by 3 minus x. Ma'am, how come? Let me write the property. If at all a to b f of x dx is there, here what you can do is you can replace x by a plus b minus x. X will get replaced by a plus b minus x. So here x will get replaced by 2 plus 1 minus x, 3 minus x. Okay. Now just, there is a trick of such questions that I give you in JEE Ninja technique. Okay. So before even solving, I can write the answer. What is the answer? Integration is upper limit minus lower limit by 2. So this is upper limit 2 minus 1 by 2. 1 by 2 will be the answer. 1 by 2 is the correct answer. Okay. Getting it? Okay. So now just this is first equation. Apply King's property. I is equals to 1 to 2 square root 3 minus x upon square root. If you replace this is x, this is 3 minus x. So after applying King's property, by the way, do not write that this is a King's property in your examination. 200 plus PYQ on 6th March I am gonna take, okay, in the evening session. 6th March. Okay. So yes, can you see this now? Can you see this? This is your after applying King's property. Remember I told you the trick. What is the trick to apply King's property? Apply King's property and then add. But before adding, make sure that the denominator of before and after should be same. Denominator of before and after should be same. So if you add, your denominator will be root x plus root 3 minus x. And this is root x plus root 3 minus x. And this is dx 1 to 2. Okay. Right. So this is 2I is equals to 1 to 2 dx. Correct. Now this is 2I is equals to x 1 to 2. So this is 2 minus 1 is equals to 2I. I is going to be 1 by 2, which we predicted earlier as well. Now I told you that the answer is going to be half. Answer is going to be half. Okay. All right, clear? So now one homework question I can give you. I can give you one homework question right away, which is this. Solution is already included. Same question can you see is given over here. So what will be the answer, Acha, by the way? What will be the answer? What will be the answer? Okay, and I'm going to tell you how to write also. Answer will be 3 minus 1 by 2. How to write this? Let me just tell you that suppose this is your original integration. This is your King's property. So you need to write the King's property in box. Okay. Now you apply King's property and adding 1 and 2. So after applying, you see that denominators are coming same. Then only proceed to add. So 2i is equals to this. Now this is getting cancelled out. 2i is going to be 1. I is going to be what? 1. That's it. This is applicable for a couple of questions. So see, now you must be thinking, ma'am, when to apply this property, but when to apply and when to not apply. So understand, when you apply King's property and get the denominator, even after application of King's property, can you see the denominator became same? That means this is the point that you are going in a right direction. Apply King's and add. Okay. Now let's do one more question. This is a MCQ. This is an MCQ. Do you remember this formula? Which formula is this? It will be like a application of integration and differential equation will be approximately combined 2 hours or more than 1.5 hours, but 2 hours. Less than 2 hours we'll be doing. Okay, less than 2 hours. Because recording, if I'm going to record, it is going to be take less time. See, if it is live, then it is an interactive session. If it is in recording, then it is going to be proper recording. Okay. So see, what is this? Clearly, that 1 upon square root a square minus x square. All the Gajnis in the chat box. All the Gajnis in the chat box, I challenge you that make a tattoo. Kalpana was killed. No. Integration of 1 upon a square minus x square. Sine inverse x by a. I need to watch. Okay, so this is what? This is sine inverse x by 3. Upper and lower limit right away. If you put upper limit 3 by 3, sine inverse 1 is pi by 2, lower limit is 0, option C. Easy? Easy or not? Okay, so I want to see one of my student getting tattooed that integration of 1 upon square root a square minus x square, integration of 1 upon x square plus a square. Flaunt it. Here there is no 1 by a in sine inverse formula. Here there is 1 by a in sine inverse formula. And on back side you can do this tattoo. Take sine x is equals to t. And do write on the back that do not forget to change integration limits. Otherwise you are cooked, bro. Otherwise you are cooked. Okay. sin x is equal to t. Now just change the upper and lower limit. You put x equals to 0, you get t is equals to 0. Okay. Students are saying, sorry ma'am, my mom will scold me. Wear full clothes in your home then. Full clothes. Like in there is so much hot, humid weather and you are wearing full sleeves. Wow, what are you hiding? Ma'am, mommy, indefinite integration I am hiding inside my t-shirt. And substitution method also I am hiding, okay? So this is pi by 2. You put pi by 2, t is equals to 1. So now understand this is tan inverse sin x is t. So this is cos x dx is dt. Correct? So sin 2x can be written down as 2 sin x cos x. So now cos x dx will become dt. So now what do I have? 2t. That's it. 2t. Yeah, that's it. That's it. That's it. That's it. Okay. Now I don't know who is going to tell me. Slipper short. You guys are so scared of your moms. Nobody is writing my dad will scold me. You guys are scared that mom will like throw chappal and what not. Huh? Don't do this, huh? Yes, Virendran, that's what. You have to expand sin 2x. Now can anybody tell me there is something which I have not taught you in this session which we are going to apply over here, and then you'll be like, ma'am, you're always like this. Why are you always like this? Yes, I got this. Isolate. Okay, isolate. So by parts, how to apply by parts? So the formula is first function constant integration of second minus integration of first ka derivative and second ka integration. Okay, this is integration of first and second function. So first of all, this is the formula, right? But you have to pick at least which function is first, which function is second. Isolate rule says that inverse trigonometric function get the first priority. So here inverse trigonometric function is there. If not inverse trigonometric function, then start finding logarithm. If not logarithm, start finding algebra. If not algebra, start finding trigonometry. Last priority will be given to e power x. So whenever you see e power x, don't think mark it second, other will automatically be the first function. This is first, this is second. So over here, but also constant. Tan inverse t being constant. Integration of second function is t square. Okay. Minus integration of derivative of first. Derivative of first. And integration of second. That's it. Okay. So if you put one upper limit. So this is tan inverse 1 into 1 square. So pi by 4. Lower limit will be 0. But you have to integrate this, which is t square upon t square plus 1 integral dt. Okay. So you need to add 1, plus 1 and minus 1. Because plus 1 if you do, so this is pi by 4 minus. If you do plus 1, this is minus 1 dt and minus minus plus 1 upon t square plus 1. This is dt. So your final answer will be what? Pi by 4. If you integrate this t. Okay, so pi by 4 integration will become 1 and this is tan inverse t. This is 0 to 1. So this is pi by 4. So pi by 2 minus 1 will be the answer. Yes or no? Have a look. Pi by 2 minus 1. Not audible you are saying. Audio breaking you are saying. You are failing all my mics. All my expensive mics are useless I feel today. This is, just go and check on Amazon. This is not given by Vedantu. This is my personal investment by the way. 13,000. This is given by Vedantu, but this you don't like. And this is something which you are not only liking. I think I should spend some more money and I should buy a Rode mic. What do you think? 22,000 rupees. I am going to I'm going to be broke then. Okay? For 1 month, no rent, no ration. Okay? Only mic. When I'm hungry, I'm gonna eat my mic. Okay? Adam is saying only 13k. 13k, you're telling me that it's less. Ma'am, spent 60k. Spend. No, I can't do that. All possible models we are doing. See, this is the question. That's how we do. Have a look one more time. See, what did we do? Sin 2x will be written down as 2 sin x cos x. And this is tan inverse sin x. So this is a big question but not very difficult. Put sin x is equals to t, cos x dx become this, cos x dx become dt. So now your question became this. Now by parts. First function constant, integration of second, minus integration of derivative of first function. So derivative of tan inverse t is this and integration of second. Now you just do one thing, integrate this by adding 1 and minus 1. So you just done with that, put the upper and lower limit and you'd be done. Okay? I don't trust on you guys. Sometimes I'll be like, okay, this is the best possible mic in the entire universe, and you'll be like, ma'am, not audible. Ma'am, I can't hear you. So I don't trust you guys. Okay? Alright. Okay, one more question. This is, by the way, okay. Very good question, I don't know how many of you left because we are almost done with today's session. But this question is a little bit on trickier side. How to do? What to do? Trick, ninja trick. Time for ninja trick, otherwise you won't be able to understand. Ninja trick says that whenever you see algebra, that is mostly algebra mein, that is x. You see x and trigonometry combined in definite integration question. I don't know. I have given this trick while teaching you JEE also. Anybody wants to say it that what should we apply whenever see this x is there. Whenever you see x and trigonometry together, you'll be like, no ma'am. You'll be like, no ma'am, not happening. Algebra and trigonometry can't be together in integration. If you talk to me that ma'am, it is an indefinite integration question, I'll be saying no, go away. But since this is a definite integration, we can use the property. What is this property? King's property will be applicable. King's property. Apply King's property and add. So King's property and add, you will see the magic. King's and add. And see the magic. See the magic. What will happen? Let us know. Let us execute and know. Okay. So this is your I. First equation. Correct. If I apply King's property says that 0 to a f of x dx is 0 to a f of a minus x dx. Yes or no? Yes. So clearly this is x. Pi by 2 minus x dx upon 1 plus cos 2 times pi by 2 minus x is going to be cos pi minus x. Cos pi minus x. Sorry, this is pi by 4, right? Pi by 4. So cos 2 times pi by 4. So this is cos 2 times pi by 4 minus x plus sine 2 times pi by 4 minus x. Okay. Now can you see this is there, but this cos pi by 2 minus 2x, cos 90 minus 0, this will become sine, this will become cos. So now your I will be pi by 4 minus x dx upon 1 plus sine 2x plus cos 2x. First of all, I have already told you that whenever you apply King's property, your denominator should be same. This is not second, this is the second. Your denominator should be same. Can you please check, is denominator coming same? Yes ma'am, denominator is coming same. So now you need to add 2i. Just I to I. Now this is your x, this is your pi by 4 minus x. Since denominator is same, this is 1 plus sine 2x plus cos 2x. If you add x and pi by 4 minus x, you are just going to get pi by 4 dx. Did you see the magic? Magic is you just got rid of algebra. There is no x pending left over here. Okay. Alright. So yes, that's about it. So this is what we have done and we are left with this. This is what we have got. Okay. So big question. I think big question. This is a high weightage, high marker question, right? Yes. So we are here. Can you see now? I can just cancel it out. This is 2 and this is going to be 8. So I is equals to 0 to pi by 4, pi by 8. I is equals to 0 to pi by 2. Okay, pi by 4, sorry. Pi by 8. 1 plus sine 2x plus cos 2x dx. Correct or not? Now ma'am, how to? Now this is an integral. How to solve? How to solve? So what you need to do is put sine 2x is equals to 2 tan x. Remember this formula? And cos 2x. Remember this formula? And put sec square x dx is equals to dt, because you are going to put tan x equals to t. This is the whole solve. You just need to execute. A little bit lengthy equation is there. Okay. Let's do it. So let's pi by 8, let's take out. 1 plus sine 2x. Okay. So this is 1 plus 2 tan x upon 1 plus tan square x plus 1 minus tan square x upon 1 plus tan square x. Now if you take LCM, you will realize 1 plus tan square x will go here and it will become sec square x dx. So sec square x dx upon, this is 1 plus tan square x plus 2 tan x plus 1 minus tan square x. Okay. So now if you put, this is your dt upon, this is going to give you 2t plus 2 integral. If you put tan x equals to t, 0 to 1, pi by 8, and this is your I. So this is going to give you what? Pi by 16 log of mod of t plus 1, upper and lower limit 0 to 1. You put 1, you get log 2, you put 0. So pi by 16 log 2 is the correct answer. Pi by 16 log 2 is the correct answer. Okay. One more last question, let's see. Any doubts in that? Last question, we are at the last question. Then NCERT important questions right away I am going to give you, either today or tomorrow morning, okay? Anonymous, we are going to see. Let me just write, okay, over here, that AOI plus differential equation will be provided tomorrow, because we have a session today, right? We have a session at 6. So let's wind up at definite integration. Let's take half an hour break. Okay, do not study anything in that half an hour. Ninja ma'am is telling you, just go watch some sky, because so much screen time. Wash your face, eat something refreshing, green tea, have something, some juice or something like that. Okay, and then come back. Okay, so 6 to 8, we are going to kill 6 to 8, 8:15. Let's see. Before 8:15, we'll try to finish 100 MCQs. Okay, alright. Okay. So this is how it is done. Now next question is 2024. Okay, can you see what kind of question? Chalo, this you are going to tell. Santosh, today evening we have a short MCQ session. I hope that you are aware. Let me show you. By the way, this is the last question. Let me just show you right away. Okay. Okay. Your channel. Then we are having live. Then we are having this. And we are having this session today only. Can you see this on the channel? See this on the channel, right? Like it. Like it. Like it. Here there is something marry me. Marry babe. I don't know why, what parallel universe going on in the chat box. Ignore it. Like it. Okay. So I'm going to see you. Make it at least 100 likes before 6 p.m. Huh? Make it 100 likes before 6 p.m. Okay. See. Now, which option is correct? A to B. Clearly, King's property says option B is correct. Sometimes, this is 2024 MCQ. Please come on. You look at it, you get the answer. NC important questions yet Ganapati I'm going to give. Anonymous, I'll try to record today. I'll provide you in the morning, or let's see. Or morning 11 o'clock I'll try to take live. Let's see. Whatever is feasible for me, I'll do it. But I'll give you before 11:12. Okay? Okay? So this is the question. So on this note, we are going to end today's session. We are done with everything. Okay? Now I'm gonna see you at 6. Okay? At 6. Make sure that you like the session, this one and MCQ session, and all the upcoming session also do like it. Okay? And just drop in some comments. Application of derivative and differential equation. Definitely I'm going to provide along with most important NCERT questions. Okay? So this is me, your Ninja ma'am, signing off. I'm going to see you in a while at 6 p.m. sharp. Okay? PDF right away I'm going to give you. Okay? See, let me just do it in front of you. File. PDF. No, sorry, no import. Export. Export. PDF. What is the... So this is integration. Integration. Okay? CBSE Maths. Ninja ma'am. So that you remember which session PDF is this. Okay? And I'm going to